Hello, everyone, and welcome to Best Practices for Amazon S3. I'm Adnan Panju, Product Manager for Amazon S3. My goal today is to cover a number of best practices that you can take back to your business and organizations and benefit from them. We'll dive into different storage classes S3 offers, look at some cost optimization opportunities, how you can protect your data, capture storage insights, and a few best practices that we recommend. And then we'll tie it all back together with a summary. Let's start with an overview of Amazon S3. Most customers in the cloud use Amazon S3 as their storage and data lake solution because it has the most functionality and unmatched availability, durability, and scalability. The one feature I would like to highlight here is scalability. Scalability is one of the key benefits of S3 storage, as it frees you up to focus on more important aspects of your business. It's easy to get started and grow to petabytes of storage without worrying about capacity planning or hardware. The storage scales as you do. Now, once you've decided to move your data to the cloud, we have a number of different ways to help you do that. And I'll provide an overview on a few of them. So for streaming data, you might want to use different Amazon Kinesis services. One of the benefits of using these, and really a best practice when you think about using Amazon S3, is that you might have smaller files, things like logs that are being sent over a period of time. It might make sense to aggregate them into a larger file before they land into S3. That can help with request costs and can also make it easier to manage your storage. Another option is to physically transport the data to the cloud. If you don't have good network connectivity, or if it looks like it's going to be faster to actually ship the data to AWS, we have the Snow family of services for you, like Snowball Edge and Snowmobile. We've also got services for SFTP transfer. Then you have things like Data Sync and Amazon S3 Transfer Acceleration that can help you move data faster to and from the cloud. And then you can also connect to on-premise applications through Amazon S3 Private Link without using public IPs or proxy servers within your VPCs. Now that you've moved your data to Amazon S3, let's look at the different storage classes that are offered and how you can get the most out of Amazon S3 and really save on cost as your data access patterns change over time. So since its introduction in 2006, Amazon S3 has constantly innovated on behalf of customers to make cloud storage more cost-effective and easier to manage. The graph you see on the left shows the over 80% reduction in S3 standards price since 2006. And then on the right, you can see how we've continued to add more storage classes over time. Most recently, we launched new archive access tier and deep archive access tier to our intelligent tiering storage class. This offers up new opportunities and more convenience when you're thinking about managing data in the cloud. We also added Amazon S3 on Outpost, which delivers object storage to your on-premises AWS Outpost environment to meet local data processing and data residency needs. Amazon S3 has a number of storage classes to choose from. Whether you have demanding performance needs, unknown access patterns, infrequently accessed data, archival needs, or data residency requirements, S3 has a storage class that is optimized for your data access, durability, and cost needs. We'll start from the left side of this slide. If you know that your data is active and frequently accessed, S3 standard is the best choice. It's designed for 99.99% availability, millisecond latency, and protection against a single AZ loss. There's no minimum on object size or storage duration, so really any data can be put here. But for a lot of our customers, it's not a one-size-fits-all solution, and you can really get a lot from using our infrequent access and archive options. You'll notice S3 standard infrequent access and S3 one-zone infrequent access storage classes on the slide here. As the name implies, these storage classes are optimized for those infrequent access workloads. If you know all your data is less frequently accessed and retained beyond a month time horizon, use S3 standard infrequent access to save up to 40% on storage costs compared to S3 standard, but with a retrieval fee for accessing the data and a minimum storage duration of 30 days. You can also archive objects via lifecycle policies from any S3 storage class into Amazon Glacier and observe up to 40% lower storage costs compared with S3 standard infrequent access, and even lower storage costs with Glacier Deep Archive. And then you have Amazon S3 on Outpost that delivers object storage to your on-premises. Let's talk about S3 Intelligent Tiering Storage class. Intelligent Tiering Storage class monitors access patterns on a granular object level and moves objects between 4 access tiers to optimize cost automatically. It's the only cloud storage that automatically delivers cost savings by moving objects between 4 access tiers based on changing access patterns without requiring any analysis, operational overhead, or retrieval fees. For objects that are really rarely accessed and are ideal for archiving after some time, we launched a new archive access tier and deep archive access tier last year. That can save you up to 95% on storage costs when objects move to deep archive access tier. Couple of things to note here. There is a monitoring fee in exchange for us doing that object level tiering. So because that monitoring fee is at an object level, what you want to think about is your object size and how long that data is going to stay around. So if you're only going to store the data for 30 or 35 days, you're not really going to take advantage of having that tiering. So you want to think about objects that you're going to store for longer periods of time, like 3 months, 6 months, a year, or even more. Secondly, you also want to pay attention to the object size. If they're megabytes or gigabyte size objects, when they move to infrequent access tier and archive access tier, you're getting that blended storage cost that's lower and your monitoring fee factors in less compared to the overall storage bill. Whereas if you're moving a lot of objects that are kilobyte in size to intelligent tiering storage class, you might not see as much savings because more is being spent on a monthly monitoring fee due to the smaller object size. So that is something to consider as you think about adding objects to intelligent tiering storage class. Now you may consider managing the transition of objects across the different storage classes by yourself. And if you have an in-depth understanding of how your objects will be accessed, you may be able to further reduce costs with lifecycle policies. S3 lifecycle policies are rules you can set up to move objects to another storage class after a given number of days. These rules are based on creation date of the object and can be filtered to apply to the whole bucket, prefix, or tagged objects. You can probably picture a scenario where a data is read for a lot for the first 30 days, and then infrequently for the rest of the year, and then finally, nobody ever accesses it again, but you have to keep it for 10 years. If you've got storage that meets that needs, lifecycle policies are a great fit because you have such predictability in your access patterns. So to put it together, there are 2 options you can choose from. If you have predictable access patterns and want to manage the transition on your own, use S3 Lifecycle Management. If you have changing or unknown access patterns, I encourage you to use S3 Intelligent Tiering. And even consider putting your data initially into Intelligent Tiering right off the bat so you can take advantage of that automatic cost savings. Now, speaking of lifecycle, in addition to using it to transition your data from one storage class to another, you can also create lifecycle policies to expire objects that you no longer need. For example, here we are using a multi-part upload API to upload a large object in parts and then creating a lifecycle configuration to abort an incomplete multi-part upload if it doesn't complete within 7 days. This way, there is a rule in place and you won't continue to pay for storage on the parts that are in S3 if the multi-part upload goes beyond the 7-day time horizon we've specified in the rule. Now let's talk about performance. A few things I want to mention here for performance best practices. First is use the latest version of the SDK, which is something you can do fairly simply depending on how your applications are set up. Upgrading to the newest SDK, you'll get things like automatic retries, handling timeouts, and then parallelize upload and download behavior. So for example, using multi-part upload, you can actually fan out large object uploads across more of S3, resulting in that happening much faster and speeding up the overall application usage. And then we have a paper that we put out on Amazon S3 performance. Among other topics, it talks about how you can use cache for frequently accessed content. So for example, you may have applications that store data in Amazon S3 as their working data set, repeatedly requested by users. In those scenarios, you can use Amazon CloudFront, Amazon Elasticache, or Amazon Elemental Media Store to optimize performance. Successful cache adoption can result in low latency and high data transfer rates, and with fewer direct requests to Amazon S3, it can also help reduce cost. You can also think about scaling horizontally. So more threads, more connections to your data, it helps distribute the load over multiple paths through the network, resulting in more throughput. Let's talk about consistency. 15 years back, S3 launched with eventual consistency, and millions of customers have used it as the foundation for their data lake and modern applications. But we've heard from customers that S3 could be even more powerful if we could strengthen that consistency. And strong consistency would allow them to streamline analytic workloads. So we launched strong read after write consistency automatically for all applications on any storage request at no additional cost. There are no changes to performance or availability that you've come to expect with S3, and we don't sacrifice regional isolation for applications. What this means is that once you write, you can immediately read it or list it. You don't have to put in place any workarounds or add any infrastructure to strengthen S3 consistency. Now let's dive into data protection with S3. One feature to consider here is S3 versioning. The way it works is when you put a new object into a bucket, it gets a version ID. Then when you override that object or add additional objects with the same key name, you're adding a new version ID. So when you issue a GET request against this object without specifying the version ID, you get the latest version of this object. You can also issue a GET request against a specific version ID if you want. S3 versioning allows you to keep multiple variants of an object in the same bucket. You can use versioning to preserve, retrieve, and restore every version of every object stored in your Amazon S3 bucket. As a best practice, enabling versioning allows you to easily recover from both unintended actions and application failures. Now, if you delete an object without a version ID, Amazon S3 inserts a delete marker, which becomes the current object version. This way, you can always restore the previous version. And when you issue a GET request on an object with a delete marker, it leads to a 404 error. But let's say you want to delete an object with a specific version ID. In that case, S3 does not add a delete marker and instead actually removes the version of the object from your bucket. Now let's say you have versioning enabled and you delete the object without specifying the version ID. As we saw earlier, a delete marker is added to the object. Then you may decide to delete all the non-current versions of the object. What you're left with is an expired object delete marker, which you can remove using a lifecycle action as shown with the XML here. And as a best practice, removing expired object delete markers can improve the performance on your list operations. Another feature a lot of our customers use for data protection is S3 replication. S3 replication is an elastic, fully managed, low-cost feature that automatically replicates objects between buckets to help you meet your compliance, business continuity, and data sovereignty needs. S3 replication gives you several options. For example, you can replicate within the same AWS region with S3 same region replication, or to different AWS regions with S3 cross-region replication. And if you need predictable replication backed by an SLA, S3 replication time control lets you replicate objects within 15 minutes of upload. So you can consider using this for most critical data sets where you need to make sure that the replica copy is there in a predictable period of time. There is a fee associated with replication time control, so you may want to decide to apply this to only a subset of your data where it is needed. You can also replicate from a single source bucket to multiple destinations. And furthermore, we also have two-way replication of object metadata. So you can create shared datasets across multiple regions and keep all object metadata in sync to and from the source and destination bucket. And finally, we have replication metrics for destination buckets. You can enable per destination level metrics and notification for each replication rule. You can track bytes pending, operations pending, and replication latencies between source and destination bucket through S3 Management Console or on Amazon CloudWatch. As a best practice, you can monitor the replication failure events to quickly diagnose and correct any issues. Now let's talk about a few of the analytics and insights tools on S3. Customers use Amazon S3 to store large shared datasets across tens to hundreds of accounts and buckets, multiple regions, and thousands of prefixes. Managing, optimizing, and reporting for these shared datasets can be challenging. S3 Storage Lens gives you that organization-wide visibility into your object storage usage and activity, with drill downs to generate insights at the account, bucket, or even prefix level. It consists of a large number of metrics, 29 in total, even more in fact if you count derived metrics. Metrics are updated on a daily basis, so think of it like a daily snapshot to see how storage and activity occurred by the end of the day. You have up to 15 months of historical data to analyze, which enables you to analyze long-term trends and patterns. And with a highly visual interactive dashboard, which is embedded in the S3 console, you can slice and dice, drill down, and perform many other standard dashboard interactions on your metrics. Finally, Storage Lens also gives you recommendations on how to optimize cost on storage. So with over 29 plus metrics on your storage usage and activity, there is a broad range of use cases. Let's discuss 4 key use cases. First is summary insights. These are top-level learnings like how much has my storage increased across my entire org in the last 90 days. Second is outliers. These are callouts for unusual upward or downward spikes based on a statistical evaluation of your data over the last 30 days. Third is data protection use case, where you can use metrics to identify gaps in your data protection policies, such as replication, encryption, or object lock. And the fourth use case is cost efficiency, where you can surface insights that may point to potential storage cost reduction, such as identifying infrequently accessed buckets. Now let's take an example of a customer that has identified a group of data that is infrequently accessed. They may decide to transition those objects into S3 standard infrequent access storage class, as it can save them up to 40% on storage costs compared to S3 standard. Once the transitions are complete, the storage administrator can quickly look at the Storage Lens dashboard and see that about 60 terabits of their data has transitioned to standard infrequent access storage class. And the dashboard gives them that overall account level view. Another feature we have is S3 request metrics on Amazon CloudWatch. With this, you can monitor Amazon S3 requests to quickly identify and act on operational information. You can enable request metrics at the bucket, prefix, or tag level. It gives you a lot of flexibility to hone in on exactly the storage you want to learn about. For example, you can learn about bytes uploaded, latency, error rates across different prefixes, to just name a few. For example, you might be expanding into a new region and are interested in how your application is performing for the end user. With request metrics, you can get that minute-by-minute metric to see how much traffic is flowing to that new application and get some quick insights. You can also monitor for any 400 or 500 status errors on your application. And then we offer percentile metrics on CloudWatch for your S3 requests. These percentiles can help you spot outliers and understand the distribution of access patterns. So as a best practice, customers use CloudWatch metrics to visualize their request patterns and alarm on these outliers to manage their operations. Now let's look at some of the security best practices. With Amazon S3, security is at the core of everything we do. Amazon S3 buckets are private by default, and the buckets and objects you store in S3 are secure by default, and we give you granular control to share that access with others. These include block public access, encryption by default, bucket permission checks, access points, and access analyzer. We'll talk about a few of these features in the following slides. First, let's look at block public access. Here are the 4 different settings you can have with block public access feature. First one blocks new access control list. So if anybody tries to upload an object with a public access control list, granted, that put will be denied. The second one says, I might already have a lot of public access granted through my existing object access control list. So enable that setting to block access through that option as well. The third one is blocking new bucket policy that grant public access. And the last one is block public access granted through existing bucket policies. So you have 4 different controls, and for a lot of our customers, it's going to make sense to enable all of them. But depending on how you're using S3, it might make sense to enable some combination. As a best practice, we recommend this feature for all accounts and buckets where public access is not intended. An approach you can take is to move all your public buckets to a dedicated account, and then for all other accounts, you can turn on block public access. The account level block public access setting will then apply to all new buckets created in that account. It's easy to set block public access at the bucket or account level, and you can do it right from the S3 management console. For encryption, Amazon S3 provides default encryption as a bucket level setting that ensures all data put to that bucket moving forward are encrypted. If you specify encryption as part of a put request, that encryption will be used. But if you do not specify encryption or somebody is uploading objects as unencrypted or with no encryption specified, then the bucket default will apply to those objects. So this applies to new objects, and as a best practice, we recommend enabling default encryption on your bucket as an added layer of protection. Another encryption feature we support is S3 bucket keys. Today, many customers use AWS Key Management Service, KMS, as a simply highly available way to control encryption of S3 objects. Traditionally, when customers use server-side encryption with KMS to protect their data, S3 makes a corresponding encrypt or decrypt request to KMS for each object put or get. As a result, customers with millions or billions of objects could generate large volume of requests to KMS. And at scale, heavy traffic between KMS and S3 increases the cost of storing encrypted data in S3. S3 bucket key reduces that cost by creating a bucket level key by KMS and is stored in S3 to create unique data keys for objects in a bucket. The bucket key is temporarily retained within S3, so S3 doesn't need to make requests to KMS to complete encryption operations, and you get increased performance with reduced request costs. So if you're using KMS for your encryption, I recommend you consider S3 bucket keys. Next, let's talk about access points. Access points are unique host names that customers create to enforce distinct permissions and network controls for any request made through that access point. You no longer have to manage a single bucket policy with hundreds of different permission rules that need to be written, read, tracked, and audited. Instead, with access points, each user or team can have their own access point with its own policy. Additionally, you can restrict access points to VPC-only access. And then we have Access Analyzer, which is another S3 console feature that monitors your bucket permission and gives you visibility into public and cross-account access. Additionally, it gives you ways to remedy public access that is not intended and to acknowledge public access that is intended. And the last thing I would like to highlight today is S3 Object Ownership. It's a new S3 feature that enables bucket owners to automatically assume ownership of objects that are uploaded to their buckets by other AWS accounts. By default, an S3 object is owned by the AWS account that uploads the object. S3 Object Ownership gives you a simple bucket setting that changes this default behavior, so that new objects uploaded with the bucket owner full control access control list will instead be owned by you. Whether your S3 bucket receives data from other AWS accounts or stores output from AWS services like AWS CloudTrail, S3 Object Ownership simplifies the work of creating and maintaining shared datasets on Amazon S3. Now let's do a quick recap of the best practices we just saw. We looked at the portfolio of storage classes that Amazon S3 offers, and whether you have demanding performance needs, unknown access patterns, infrequently accessed data, archival needs, or data residency requirements, S3 offers a storage class that can meet your data access, durability, and cost needs. We also looked at S3 Lifecycle Management to transition objects from one storage class to another, and S3 Intelligent Tiering storage class, which monitors access patterns on a granular object level and moves objects between 4 access tiers. So if you have predictable access patterns, use S3 Lifecycle Management to optimize on your storage costs. But if you have changing or unknown access patterns, use S3 Intelligent Tiering storage class to automatically move objects between 4 access tiers without requiring any analysis, operational overhead, or retrieval fees. For data protection, we recommend that you enable versioning to recover from both unintended user actions and application failures. And then we also recommend using S3 Replication to automatically replicate objects between buckets to help you protect your data and meet your compliance, business continuity, and data sovereignty needs. For analytics and insights, we talked about using Storage Lens to get that organization-wide visibility into your object storage using usage and activity. And then we talked about S3 request metrics on Amazon CloudWatch. With this, you can monitor Amazon S3 requests to quickly identify and act on operational information. And then with percentiles on Amazon CloudWatch for S3 requests, it can help you spot outliers and understand the distribution of your access patterns. Lastly, we looked at some of the security features, and here we recommend turning on block public access for all accounts and buckets where public access is not intended. We also talked about enabling default encryption as a bucket level setting for that added layer of protection on your objects. And lastly, we looked at S3 bucket keys, and with that, you can increase the performance and reduce request costs for KMS-backed server-side encryption. So this concludes our presentation on best practices for Amazon S3. Thank you all for joining.